C++ bitwise OR operator. The bitwise OR operator consists of, okay, so bitwise OR operator return 1 if at least one of the operand is 1. So otherwise it returns 0. The following truth table demonstrates the working of bitwise OR operator. Let A and B be two operands that can only take binary value, that is 1 or 0. So A consists of 0, 0, 1, 1. This is the fixed value. Then B consists of 0, 1, 0, 1. This is the core condition. This is the truth table is fixed, so no changes is there. Okay, so your operator is OR, single OR, that is bitwise OR. So A or B. So the first condition, A equals to 0 and B equals to 0, the OR operator is 0. Okay, A equals to 0 and B equals to 0 means A equals to false and B also false. Then it gives the result is false, means 0. Okay, so A equals to 0 and B equals to 1. According to the condition of OR operator, it gives the answer 1. Then A equals to 1 and B equals to 0. Then again it gives the answer is 1, because at least one condition, at least one operand is 1. Okay, then both the A and B consist of 1, that's why the OR operator always gives the 1. Okay, let us this example. We can also the example of bitwise operator, bitwise OR operator, I am explaining in detail in next lecture. So uh, in this lecture you have to see the introductory information about the bitwise operator and the explanation of each operator with example is for understanding uh, for understanding its consists of so difficult, so I am giving it in next lecture. Okay, so third operator is the bitwise X operator. So the bitwise X operator returns 1 if and only if one of the operand is 1. If and only if one of the operand is 1. This is the XOR operator. Okay. However, if both the operand are 0 or if both are 1, then result is 0. So this is the some logical statement. Okay, please carefully listen. Again I am repeating, bitwise operator returns 1. कब return 1 करेगा? If and only if one of the operand is 1. Means दोनों में से कोई भी operand अगर 1 है तो ही वो क्या return करेगा? 1 करेगा. Otherwise if both the operand are 0, मतलब दोनों भी operand अगर 0 है, या फिर if both the operand are 1, या फिर दोनों भी operand अगर आपके 1 है, then the result is 0. This is the XOR operator. So please see the table. A equals to 0, B equals to 0. The XOR operator returns 0. A equals to 0, B equals to 1, then it returns 1. Okay. Then A equals to 1, B equals to 0, then it returns 1. Then A equals to 1 and B equals to 1, then it returns 0. Okay, so please carefully note down this operator. The example of this operator I am explaining in next lecture. So, and also explaining the program also. Fourth one is the bitwise complement operator. Complement means opposite. It is complementary operator, means it is just like a logical NOT also, but it consists of the bit level. Okay, the bitwise complement operator is a unary operator. It is also called as tilde operator, work on only one operand. Okay, it consists of only one operator, one operand. It is denoted by tilde sign that changes binary digits 1 to 0 or 0 to 1. It just like opposite. अगर आपका ट्रूथ टेबल मीन्स अगर आपकी वैल्यू ए इक्वल्स टू अगर 0 है तो बिटवाइज कॉम्प्लीमेंट्री ऑपरेटर क्या करेगा? 0 का 1 करेगा और 1 का 0 करेगा. ओके, so please note down note down the complement bitwise complement operator, draw the or write down this figure also. It is important to note that okay, it is important to note that the bitwise complement of any integer n is equal to minus n plus 1. For example, this is the I am explaining in example. So this is the formula n is equals to minus a minus bracket of n plus 1. Okay, so the next operator is the in bitwise operator it consists of very different operations. So I am explaining in next lecture. Okay, so the last operator is the C++ shift operator. It consists of the two operators, that is right shift operator and left shift operator. Right shift means your extraction operator and left shift operator is nothing but the insertion operator. Okay, so the first is the right shift operator. So what is mean by right shift operator? The right shift operator shift all the bits towards the right by a certain number of a specified bits. It is denoted by insertion operator. Sorry, it is denoted by extraction operator. Then we shift any number to the right, the least significant bits are discovered while the most significant bits are replaced by 0. Okay, so please write down the figure. This is the shifted one bit shift right side to towards. Okay, so as we can see the from the image above, we have a 4-bit number. And when we perform a 1-bit right shift operation on it, each individual bit is shifted by the right side by 1 bit. Okay, मीन्स ये क्या होता है कि जो बिट है हमारा each and every bit shifted to the right side. I am explaining in the next lecture and give the more details notes by the right shift operator and left shift operator. So first of all, please listen. Left shift operator. The left shift operator shifts all bits towards the left by a certain number of specified bits. It is denoted by insertion operator. Okay. So this is the example. All bits which is shifted towards the left side. Okay, by 1 bit. Okay, as we can see from the image above, we have a 4-digit number. We perform a 1-bit left shift operation on it. Okay, each individual bit is shifted to the left by 1 bit. Okay, as a result, leftmost bit is discovered while the rightmost bit remains vacant. This vacancy is replaced by 0. I know you cannot understand what is the left shift operator, what is the right shift operator. So don't worry, student. I am giving you the full detail notes and giving you the examples of each operator in next lecture. Okay. So don't worry about it. Then you have to write down the bitwise operator. You can only write the bitwise operator table and some and the and its explanation, not write down its example and program. I am explaining in next lecture. Okay.